Thank you, Betsy. So obligatory safe harbor slide. You haven't seen this yet today, so please read carefully. So honing mobile monitoring with event data. We're going to talk you through some of the recent releases from New Relic Mobile, including some of the great new data that we're reporting into the New Relic platform. And we're also going to have some conversations with one of our customers about how they're using New Relic to deliver great experiences for mobile customers. I'm Devin. I'm a product marketing manager here at New Relic. I work on mobile. We also have Susie, our product manager. And a cameo from Matt from Dunkin, one of our customers. So we're really thankful to have Matt here on stage later. So this is the spinning wheel of death, the wheel that our customers don't want to see and you as owners of mobile applications and services want to avoid. It's just a terrible experience. And the upfront section that I'm going to talk through is going to walk through why we believe that mobile performance is a critical part of delivering a great customer experience. I mean, this is what we're trying to avoid, but it's a lot more than that as well. And I have some data to back that up. Half of one-star app reviews are because of performance issues. This is across a number of studies. And what that means for the organization is you're spending an incredible amount of money to get people to the App Store page to hit download. And we all know we've downloaded apps, we've looked at Amazon reviews. The star rating is a critical part of how you make that decision. So if you could eliminate half of one-star app reviews by fixing performance issues, that would be a huge win for your organization and a huge win for your customers because obviously they're having a better experience in delivering higher ratings. This is also a really important point, and I think Matt's going to touch on it later. But first impressions matter for mobile, and you could make the argument that these first impressions continue from every release that you're doing with mobile. So you might be releasing every week, every month, but each release of your mobile application introduces risk. And that's especially pronounced on mobile because of the nature of how you're delivering the software to the customer. It's via an app store, there's a review process. Essentially, it's going to take a little bit longer to do a rollback. So you need to be really careful about each release and that first experience from a customer. They're going to be able to switch to a different app. It's going to be a fundamental part of how they interact with your brand. And then we really get into just the start of the challenge, which is how do I retain that user over time? And there's a lot of research. This is one piece of research that shows how high the churn rate is on mobile. There's also some other research that I don't have on a slide, but shows how limited the set of applications are that a user continually goes back to. And what this really means for us is that every possible avenue that we can take to combat this retention challenge on mobile is critical for the organization. Recent update from Apple for iOS 11 highlights this, which is Apple is going to take steps to automatically delete applications if they're not seeing that user come back to them. So this is going to be something that organizations are going to see, and there's going to be more pressure on driving that retention. So performance is a feature. It's a critical part of your business. It's something that we still see in the industry today and with our customers, continuing to try and help them sell that internally as an organization. So hopefully some of those stats can help you get along that path to convincing your organization to put mobile performance monitoring into your application. So that's a little bit about the why it matters, but let's get into more on like how do you deliver this great performance. And a fundamental part of that is understanding that a mobile app is much more than what's installed on the client side. It's dependent on increasingly complex set of services on the back end, and how do you combine and work together as a team and understand what's happening. Well, Susie's going to get up and talk a little bit through about some of the recent releases that help you understand the entire platform that the mobile app is running and deliver better performance. So over to Susie.
Hey everybody, I hope you're having a good afternoon. I'm going to talk about some of the great things you can do in general to monitor performance, and I'm obviously going to highlight some of the latest data and features that we've released to help you do this. So mobile apps, they make network requests. Network requests are often a pretty big gate to the performance that an end user experiences. Those network requests aren't just blind calls into the network. They're actually calling backend APIs. And those APIs might be your own backend APIs. They might be third-party APIs. But sometimes those requests are actually going to gate the speed at which your users can actually use your app. So it's pretty important to know what's going on there. And so one of the things that we have released in the last 6 months is actually capturing specific event data to represent every single HTTP request that comes out of a mobile app and every single error, HTTP error. Because then you can actually start to connect those dots. And we saw distributed tracing in the keynote yesterday, thanks to AJ's great demo. This actually involved a real mobile app. And we were able to connect through to understand from a network request what were the backend services that were called and what was the performance of every step along the way. That way, you can actually make your mobile app end user experience much, much better. You might have network time regardless, but at least you can shrink down the back-end time as much as possible if you understand how to follow it through. To do that, we need to know every single request so we can trace individual ones through, understand exactly which route they took. So what I'm going to do first, I'm going to come back to network requests, so don't forget about those. I'm going to talk about mobile monitoring at a higher level for a second. Mobile monitoring originally was based on feedback that maybe our customers got through support channels or maybe through Twitter. And that's how people learned about issues. Well, we can evolve that, and so I'm going to walk through the different levels of mobile monitoring that there are. Customer reported issues is the first one. It's pretty awesome to have that. Like, you don't want to miss out on that. If people are having issues and you don't know in another way, you really do want them to tell you. And even if you have monitoring, you're still going to have things that you didn't catch. So it's always good to keep hearing what people are complaining about. Probably one person complains and a lot more people than that actually had the issue and just bailed without even bothering to submit a ticket. So it's good to know. This example here is for crash rate, or for crashes in general. And they're saying, hey, your app crashed on me. Maybe you knew that already, maybe you didn't. It's still pretty good information. It could be something a little simpler, like somebody tried to click on something in your app and it didn't actually do anything. That could be an HTTP error problem. So this information is helpful, but we can do better than wait for somebody to tell us about it. So metric monitoring is the basic best practices. Always do this. Everyone in here, if your company has a mobile app, make sure that they're doing this. There's some basic things you should set up, and those are crash rate alerts and error rate alerts. So it's really easy in our alerts UI to set up either of these alerts. And crash rate alerts are pretty general, so you want to make sure that your thresholds make sense. You don't want to get alert fatigue. You want to make sure that this is to highlight when things go really, really wrong. You put out a new app release, and there's something really broken in it. Or maybe there's something on the back end that suddenly breaks, so one of your hosts goes down. One of your APIs, back-end APIs, actually changes. Things are really wrong. You want to catch that, and you want to wake up for that. Same thing with errors, HTTP errors. You want to set your threshold a little liberally so you're not catching every little spike, but so that you know if things are going really wrong, and you can react very quickly. This is the alerts UI for New Relic. And with alerts, it's pretty easy. You guys might probably know this already. This is for all the New Relic products. But you can set up different notification channels. So you can send this via email, Slack, PagerDuty. You can use webhooks to actually do other integrations. You can send it to individual users, and what that means is it'll actually send them an email, plus it'll actually send them a push notification on their New Relic mobile app. So those are some different options for alerts. You can set up email lists and things like that as well. And if you do get an alert on Slack, for example, and you click on that alert link, it's going to take you into the Alerts UI. And this is what the Alerts UI looks like. The Alerts UI will highlight the particular spike and illustrate why it showed up as a problem. From here, and this one is for crash rate. From here, it'll actually link you over into our crash analysis UI page so that you can see which crash is the outlier, which one caused that big spike that you just got alerted on. So that's minimum. Best practices, definitely crash rate, error rate, set those up. What I'm going to really tell you guys to encourage you to do is what's called Newark Alerting. So you might have already heard of this. New Relic query language. You can write queries. You could be super specific about what went wrong or what you're worried might go wrong so that when you do get an alert, you know it's absolutely crucial that you respond very quickly. I'll go through a couple examples. And I'm going to tie this back to network requests. So the thing with HTTP requests is some of them are super important. So if you want a new user to register for your service, and they hit the registration button, and the next screen can't load till you get a response back from your API, your backend API, that better be fast. Otherwise, they're just going to bail out, and you just missed actually getting a new customer. If there are high error rates on other crucial things like they actually want to add something to the cart, you want to react quickly to that too. So there are ways you can be very specific about types of errors, specific endpoints, and dive in and make sure you wake up the right people for that. Not only your mobile app team, but actually the person who owns that service on the back end that might be the thing that's causing the problem. Right? So this is a way to start collaborating across teams. So that our customers can do this, which everyone's been requesting for some time, we did release new data. So this is the mobile request error and mobile request data that's now available in Insights. So you can create dashboards. You can say, I don't care about certain status code. For example, login. If a user logs into a mobile app and they enter in the wrong username or password, there'll be a 401. And maybe those are just things that happen, and you don't want that to be part of your overall error rate. You can filter those out. All right? So you can be really specific now. If you have a certain endpoint that you want to make sure gets better, you want to make fast, you want to focus in on, you can actually filter your query to only that endpoint and watch your response time increase over time after working through performance improvements with the other teams involved. So here's an example of setting up an alert that is very specific. This is for an error rate, so HTTP errors. And to do this, I'm going to do a percentage, which is a function that we have in Insights. And it's querying two database tables, mobile request error, so those are all the HTTP errors, as well as mobile requests, which are all the successful requests, so that we can see what the overall rate is. So we're doing a little bit of calculating there. The thing I really want to point out is I'm actually focusing in on one endpoint. And the way I'm defining that endpoint here is a wildcarded URL. So the request URL, in this case, might actually have a unique ID in it, which is super common. So I can use the percentage symbol to actually use as a wildcard and focus in on this is the endpoint, this is a specific service that I care about, and I want to make sure this error rate doesn't go above my threshold. So this is the same thing now for response time. So for response time, you could set up a percentile as an example. You could do max, you could do average. Again, though, I'm saying where request URL is like something. And that's how to focus in on one endpoint that you really care about and you want to make sure is super fast. That's your alert, and that's what you want to wake people up for in the middle of the night. If that's a critical business service, you want to make sure it's up and running fast. So just to keep things really exciting, I'm going to do some live demos. So I'm going to switch over to demo. All right, so here's an example dashboard, and I'm using the new data here. And I'll show you some of the example queries so you get a sense of them. So my first widget here up in the top left is just doing a count. It's seeing how many total requests, which are the successful ones, and request errors I'm having across different versions of my app. So what the query is doing is it's looking at both mobile request and mobile request error to do the query, and then faceting by app version. So this is pretty handy because I can say, all right, you know what? I can't really do anything about my older versions, but I'm going to use this to really easily select and focus in on my latest version. And I'm going to go ahead and filter to my dashboard to that version. So I did that, and it'll filter all of the different things I have on my dashboard to only version 3.1. From here, I can actually do other things. Like I can just show the count for errors that are not 401. Or I could perhaps filter out a request domain that is like my A/B testing domain, and I just don't want the errors associated with that to count against my error rate, things like that. So I can do my filtering here to figure out time series. I can figure out error rate in the same way. But it adds a lot of flexibility to tune out what you would otherwise consider noise. If anybody would say when they got an alert, if they look at it and they're like, oh, that doesn't matter, filter that out. Like you want to make sure your alerts are the things that matter and that people would actually be like, all right, this is really important. We need to address it right now. Everything else knock out of the way. Here I have response time. And the query for response time is the same that I showed you in the alerts UI for setting up an alert on response time. And I'm querying mobile request for my particular app. And in this case, I'm doing different percentiles so that you can get a sense of what the distribution is of response time across different facets of your audience. Error rate here is definitely one that I would recommend using for a Newark alert. Again, where you would actually focus in on just the things that you care about and filter out the things you don't. But to do the actual alert and to add it into the alerts UI, you would basically copy and paste this query without the time window and throw it in the alerts UI, and you have a Newark alert set up. So it's pretty easy. And you can actually check out the history of it so you know how to set your thresholds as well. That's for error rate. You can pick specific endpoints, or you can actually facet by endpoints. So for example, a lot of performance issues come around loading of images because maybe the app code wasn't written in it was too dependent on that image coming back, or maybe the image quality was too high for a certain network speed. So maybe I want to bucket all of the image API work into one service or one endpoint that I want to track. And so there is a way to set that up with what's called cases and actually bucket the requests, the error rate, the errors. You can do response time, which I have a little bit further down. Response time by wildcarded endpoint is what I call it. You can also split up response time by domain across URLs. I think you guys get the idea. What this new data provides, because we're tracking every single occurrence, is the ability to slice and dice the data in a lot of different ways and make sure you're focused on the things that you care about. So I'm going to switch back to my slides. So that's our new network event data. We've actually done a ton of other things in the last 6 months as well. So we released what's called the crash event trail, and I'm going to dive into that in more detail. We released what's a new modal in the UI to make it easier for our customers to upload their DSIM files. So if you guys are familiar with DSIM files, or if you're not, I should say, it's specific to iOS, and it's for actually translating crash reports that are essentially memory addresses back into file name, method name, line number, and information you can use in a stack trace. So it just makes it easier for our customers to upload essentially those mapping files so that we can provide nice crash information in the UI if they're not able to integrate it with their builds. And finally, the thing that we're working on currently is a new handled exceptions UI. So if you think about crashes, they're the unhandled exceptions. Handled exceptions are the ones you caught. So they didn't actually crash the app, but that doesn't mean that the user had a great experience. It could be that nothing happened when they tried to tap on something. So I'll go through a couple more demos. I'm going to do a little bit more of an intro for crash event trail. So debugging crashes, sometimes it's easy, sometimes it's really not. And so it's really nice to know the trail of events that led up to a crash. We have a lot of data. And what we're doing is we're going to pull all that data. We have done this. It's already out there for you guys. It's in the UI, in our crash UI, and can include a lot of different event types. So I'll tell you a little story about this particular session that crashed. A user launched an app. They tapped on a register button, so they want to register for a service, or they want to add create an account. And that actually triggered an interaction. That interaction was a loading of a screen. And so a certain view controller, in iOS's case, a certain view controller loaded. So the first part of this, the user tapping on that button, is something that you can track with a custom event. The reason that's super valuable is you can track over all of your sessions how many users tap that button. You can get more of that general information and understand what geography and other attributes about that user to understand that. That would be a custom event. That's something that you can custom instrument super easy. It's a call to our API record custom event with a name value pair or a series of name value pairs. Interactions we auto instrument. So that means that we know there's certain methods that are commonly used for different view controllers. And so we'll grab that information and provide that to you so that it shows up here. Network requests we now auto instrument. If you have our latest version of our agent and you turn on network request, with a feature flag, so special note on that. But in this case, the loading of the screen actually triggered a network request. And this network request was saying, hey, we have a new user here. And it gets a response back of 200. 200's good. 200s are successful. But it doesn't necessarily mean everything's peachy keen. The actual data that came back might be bad. And if the data is bad, it doesn't matter if the response came back OK. The app might still crash. And that's what happened in this case. So the way you would catch that situation is by defining a breadcrumb. And we have a new API for that as well. It's called add breadcrumb. Pretty easy. And there you can actually say, all right, so we got a response back. And these are the bits of data we need to use from that response to move the user to the next thing in the app. Oh, but there are no values there. And so you can actually record those values as part of your breadcrumb so that when you actually go in to debug a crash, you can see what's missing. And that'll help you understand why things went wrong. All right, so I'm going to switch back over to demo mode. So to show you crash event trail, I'm going to start on the crash analysis UI, which hopefully people who are working with mobile monitoring have checked out already. There are a lot of cool features you can explore here, lots of ways to figure out what to focus your time on and how to debug it really fast. What I'm going to do is I'm going to dive in pretty quickly just to show you crash event trails. So I'm going to pick a particular type of crash. And here I see the details of that crash. I can see if it's not specific to one OS version. Maybe it's not specific to a device type. In this case, it's pretty broad. We see our stack trace when it comes up. And then we have an event trail. So event trails, as I mentioned, will actually show you a whole lot of different things that happen in that session. So the first example is right before the crash, we actually had a network failure happen. Network failure is a request that was made that actually never came back. And so the OS has to determine why it didn't come back. And so sometimes it's just a timeout. Sometimes they couldn't reach the server. So there are different types of network failures. If a network failure happened and that actually caused your app to crash, that's pretty good information to know where to start looking for how to better deal with that situation. We can get a little more information about it. What was the request URL? How many seconds did this actually take? Things like that. So that's something that we auto-instrument. Here's another example of something we auto-instrument. It's the interaction. So this is the loading. This is for Android. So this is the loading of a particular fragment. Then we have an example of a custom event. In this case, if you create a custom event, you get to define what type of event it is. And so we've created a new type. If you were to query this type in Insights, you would say select star from mobile gesture. So you've created a whole new database table. And under this, I've actually said, well, the particular gesture this is the user actually pressed plans on the nav. So that was the action the user took, and you're tracking that as a custom event. That's going to help you reproduce the problem. We'll see that there is a network request here, and that's actually the network request that ended up failing. So we can track that back. It actually tells you kind of where it connects. We have a successful network request here as well, and another custom event. So you get a sense of how these show up and how these would help you debug a particular crash. That's crash event trails. I'll show you something that we're working on, not GA yet. Crash event trails, GA. Next thing, handled exceptions, not GA. So handled exceptions, we're treating very much like crashes. And they are the things that went wrong in the app that got caught, so it didn't actually crash the app, but that you still want to fix because it probably did not lead to a great user experience. So with handled exceptions, you can do much of the same as you can with our crash analysis UI. You can facet and filter. You can look for a specific user if you're capturing some sort of a user ID. You can look at their particular handled exceptions. And for each of these handled exceptions, you can then dive in, and you can actually see the stack trace associated with that handled exception, as well as all the attributes of a session. We have every single occurrence of that handled exception that you can click through. So yeah, these are things that our customers have been asking us for a long time. So I'm pretty excited to be able to present them to you and to show all the great work that the team has been doing to help you make your mobile apps much faster and more stable. I'm going to switch back to my slide deck. So what's next? So I talked about network events and how helpful that is in terms of being able to track every single occurrence so you can really debug it and filter out certain things and be very specific. So we're actually going to bring that into our UI as part of our normal mobile UI so that you can actually do that slicing and dicing in our UI in addition to Insights. So that's the next thing we'll work on after handled exceptions. So for this talk, Devin gave us a bit of an intro with the spinner and talking about the latest things that Google and Apple have declared about mobile app performance. They have made it super important. And I had talked about distributed tracing. Network requests and being able to track individual network requests is absolutely imperative to even think about distributed tracing because in order to track one trace all the way through, we need to make sure we have every occurrence. I talked about different levels of monitoring and made some recommendations and best practices about those. Really encouraging Newark Alerts to be really specific and make sure you're waking people up for the right reasons. And showed you a little dashboard about that. And then I talked about some of the other things that we've released lately as well. So all that said and done, I'm going to hand it over to Devin and Matthew.
Thanks, Susie. I think we have 5 minutes?
Yeah, you have 6.
6 minutes.
6 minutes.
So I'm going to talk with Matt a little bit about his journey with New Relic and Duncan's story around mobile. And if we have time, we'll try and take some questions from the audience. If we don't, we'll obviously hang back and you can come talk to us after the scheduled remarks are finished. So Matt, thanks for joining us again. Could you tell us a little bit more about how important mobile is to Dunkin and how you're using performance monitoring to deliver a better customer experience?
Sure. We came from a legacy application where we had no mobile APM, and it was pretty heavily used because of the good value it offered for our customers. But when we had issues with it, when we released new releases, we depended on those customers to call in and tell us what was going on. And for the most part, it became a fishing expedition or a deep dive. When we decided to launch mobile ordering, which was a year and 3 months ago, we knew it was going to be a big deal. We knew there was going to be good adoption, and we knew we couldn't rely on not having more data. So where we wanted to get to, what we knew when we were going to launch that, we needed to put mobile APM in place. We were already using New Relic APM on servers. So when we did the initial launch, we wanted to be able to answer just those basic questions. Who's using the application? What are they using it for? Where are they using it? How many people are using it? And what's going on in the environment? So that was what kind of kicked us off on that journey.
Cool, really cool. So we talked earlier, and you know, release day, I mentioned it, it's a big part of managing risk. So you can talk a little bit more about your release days and how your current state of how you managed each release.
Sure. One of the big catalysts for us releasing new versions of our application is we like to add new functionality that's going to benefit the users. So a lot of those bits of functionality come from third-party integrations, and they come to adding new features and capabilities through the UI UX. When we release, we want to make sure first and foremost that crash rate doesn't go up. So we're using New Relic Mobile APM to very closely watch crash rate on release date and to try and get that data out of what's actually occurring in the field. The worst thing that we can have is a new version of the mobile app release and see that crash rate go up. We're particularly sensitive in the Android platform because of the high degree of fragmentation and the large number of OS versions and device makers that they can behave differently. But even beyond that, very simple things like a network carrier and performance can impact how the app behaves if a network request times out. And we want to know more and more about that so that we can make sure that we're giving the best experience possible.
Great. Thanks, Matt. So the future, what are you excited about? What are you looking forward to implementing next in your...
Okay, so the future, that's fun because it was kind of happening while I was sitting in the chair right there. I was watching the presentation and I was going, well, everything I've complained about in the past, it's right there on the board. So the big challenge is right now, we're one of those groups that we pay really close attention to like network error rates. It's very important to us. We know what's normal, we know what to expect, and we do alert. And one of the key things is I don't want to be alerted or woken up, especially early in the morning, if something's not really relevant. It's kind of a typical anecdote for a lot of mobile application development. You start including third-party APIs into your application. You're starting to develop things that are including other people's code. There might be a call out to a server or a service or a third-party partner of ours that may throw an error and it doesn't impact our customers. It may just be their third-party analytics. We don't want to wake up for something like that. So NERC alerts and getting very specific and slicing and dicing the types of errors that we're getting is a big deal to us. And then additionally, the crash event trails is something that I can see our mobile devs being very excited about because they're, again, because of the number of integrations, very sensitive to the types of responses they get back, whether data is missing in a certain response. That can affect application stability, and we want to make sure that we're not walking past opportunities in that area.
Awesome. Thanks, Matt. So I think we'll wrap up. Do you have any time? I don't have any time. Yeah. Okay, so we have time for some questions if Susie wants to join us back on stage.
Yeah, we just have time for maybe one, maybe two questions from anybody in the audience. Anybody? Anybody?
Come on, bring on the questions. There's got to be something.
Well, I guess we don't really have questions. Oh, wait, whoa, we got a live one over here. All right.
How often do you find yourself finding network errors that your backend team doesn't already know about that maybe causes your mobile application to
All
go
the
haywire?
time. Oh my God, we find all the problems from the mobile app
Really?
side. So I'm the product manager for mobile APM, but I'm also the product manager for New Relic's mobile apps. So I get to kind of see a couple different perspectives. And yeah, we just ran into a problem the other day. We actually use synthetics API checks against the backend APIs in staging, so before they go to prod. Yeah, I see those alerts go off, and we already know something just broke, and we let them know. And yeah, it happens a lot. I mean, our mobile app team is amazing. Obviously, I'm biased. But yeah, they catch things pretty fast, and it's a combination of synthetics API checks and the mobile monitoring that we're doing.
Oh, there's one last one.
One more? All right. You have that?
Yeah, I have the infamous metric grouping issue going on, but it's a video app, and these are HLSTS segments that have unique names on them. And since I don't have access to that code, how do you suggest we silence this or handle it, but I still want to get those errors reported up?
So the whole metric grouping is associated with metric data. So if you start collecting your network requests and errors as event data, which just means using a later agent, then you actually won't, you can define your own grouping and insights if that helps. You have? You just have to, we can walk through, like if you want to, we can walk through how to create a dashboard and how to view it. Yeah. So basically, our current UI, just for everyone else, our current UI does limit how much you can see in terms of all the different domains and the different, for errors specifically, domains is the main issue, but maybe also for requests, the different URLs. We don't have that limit with event data. So you can go through, you can see the whole list of domains, you can see the whole list of URLs, and then you can filter out the ones that you don't want to see. So this is, and we will be moving this into the curated UI experience as well, but just to get you moving on it fast, we have example dashboards you can use too. So yeah, we don't have to worry about metric grouping anymore.
All right, and I think that's all the time we have. So thank you, Matthew, Susie, and Devin. That was awesome.